Hey class, welcome back to Chapter 9, Probability. Today we will be looking at Exercise 9C, tree diagrams. So tree diagrams are used to list the sample space for experiments with 2 or more steps. Okay, so we'll jump straight in with an example. We're going to flip a coin 3 times. Okay, we want to know what the total number of outcomes is. So to quickly review what that tree diagram would look like, on my first experiment, okay, or my first trial, okay, trial number 1, okay, I can either flip a head or a tail. Okay, on my second trial, I can flip either a head or a tail again. And on my third trial, because I'm flipping the coin 3 times, I can flip either a head or a tail. And I repeat that for every single branch, so every branch is repeated. Okay, I then, once I've made my tree diagram, and I know this is tedious, but it's okay, I list my outcomes. Okay, so the list of outcomes on the first branch, we have head, head, head. Following along the second branch, head, head, tail. Head, tail, head. And head, tail, tail. And then we repeat for the second half of the tree. So tail, head, head. Tail, head, tail. Tail, tail, head. And tail, tail, tail. So to answer that first question, what is the total number of outcomes? We have a total number of 8 outcomes. Okay, so there are 8 outcomes in total. Using that information, we're now going to calculate the probability of tossing 3 tails. So we're looking for the probability of TTT specifically. And there is only one outcome where that happens. In no other outcome do we have 3 tails being tossed. So we have a 1 in 8 chance of that occurring. What is the probability of tossing 1 tail? And it's specific about the fact that we want just 1 tail. Okay, so again, I'm going to go through my tree and I'm going to find all of the outcomes that have only 1 tail. So there's 1, there's another 1, and there's another 1. Every other option either has no tails, 2 tails, or 3 tails. So we have 3 out of 8 probability of tossing only 1 tail. And finally, what is the probability of tossing at least 2 heads? So let me maybe go green. So at least 2 heads. So we want 2 or 3 heads. So here's 1, here's 1, here's 1. There's only 1 head there. There's 2, 1, 1, and 0. So we have 4 options in total. So at least 2 heads. Okay, and there is a 4 out of 8 probability of that, which of course we must simplify to 1/2. Of course, you can write any of these as decimals or percentages as well, or you're welcome to leave them as fractions, which have been simplified. That's all there is to tree diagrams, you guys. They can get quite tedious to draw, but they are super useful, especially moving forward when we start looking at experiments with and without replacement. As always, guys, good luck with the work. If you have any questions, let me know. But otherwise, take care and I'll speak to you all very soon.